Well, hello, good morning to everyone. Thanks for the wait and for attending this webinar on the next generation radar altimetry toolbox concept design workshop. My name is Roger Escolà from ISARSAT, and I will present you the Sentinel-3 Toolbox project. This is a project under an ISA contract carried out by Demos Portugal, ISARSAT UK, and TU Delft. And it aims to update and improve the current BRAD and the radar altimetry tutorial website. So the main idea of this webinar is to present what we are doing and collect feedback from users in order to reach as many user requirements as possible. So I'll explain what this is all about. The toolbox that we are building is an evolution of the existing BRAD. I don't know if you're familiar with it, but it's the basic radar altimetry toolbox. But it includes a few new things that we think that will improve the performance of it. So we will have new data sets, new functionalities, and also a new GUI, the user interface. Apart from that, there's the website tutorial, and we will update the existing one and also create new one because new concepts have arisen, and we need to do that. And apart from that, we have another main objective, which is to reach to a major level of users, not only the expert ones, as we think it is now, and we want to support also the beginners users, and for that we need feedback from the altimetry community, and that's why we're doing this. Well, before I explain all the new features that we include or we wish to include in the future toolbox, I will show you how the current one works. And just with a few practical examples, very simple ones, using data that is already in the website, that it was done by the CNES and CLS. So I will switch to BRAD now, and I'll show you the interface of the toolbox and a couple of examples. So this is the interface of BRAD. There's four main tabs that we have to be aware of. The main one is the workspace, which is what we have to build at the beginning. Then you see that we have four tabs. The first one is data sets. The second one, operations. Third one, views, and fourth is the log. So what these tabs mean? The first one is where we choose the data set that we want to manage or view or export or whatever we want to do. In the operation tab, we have all the manipulations that we can do to the data, and where we select the kind of output that we want. And here we can export the data to external files or to other applications. And in the views, we can visualize the data that we are managing and selecting inside the same application. And in the end, we have the logs, which is a register of all the actions that are done inside the BRAD. So first, we will start. Well, I already have a workspace, but so we work with this one. It's an empty one. So the first thing is we create a new data set, which we can name for things that we will do, MVSAT curve, MVSAT, or GDR, for example. Then here we can select the files or a whole directory if we want to have more files, but for now we just use one. And here we have this data for GDR data from MVSAT. Here you see that we have the data set. Once we click on it, in the right, we see all the information that it's inside. We can see the full name, and we can sort it alphabetically or by record. So you can see have the main product header, well, all that is inside the document. There's also units, dimensions for the variables that it's applicable. So what we do now, first we have selected this data set. Now we go to Operations tab, and then we create a new operation. We name it MVSAT GDR. For now, it's this. You can select it as you want. So here in this window, we have one data set only. If we had more, you would see a list of them. And here, the fields that are contained inside the data set that we have selected. And for now, we are interested in the altimeter. Here we have all the parameters that are inside the product, and we can sort them alphabetically, which is quite comfortable for me and useful. And we will start with, with a simple plot of a track. So what we do now is we select the longitude as the x coordinate, here the latitude as the y coordinate. And in the data, we will see the range seen by the satellite. So we know that this parameter, but if not, it will be quite impossible to find what it is. And well, here we have a few options. For now, we have just selected one parameter from the product, and we can visualize it. But first, what we have to do is execute the operation. We have to make sure that it's in the units that we want. We'll set it in meters instead of millimeters, and the application does the conversion automatically. We execute the operation. We just saw the log window with the processing time and all the records. We were here, and now if we go to the views, we generate a new display. We call it MVSAT GDR again, curve. And in this box, we have all the operations available that we have for plotting. So we just take it, we drag it into the right, and once we have it here, we can execute. And in this new window, we can see the range for this whole track, starting from the south and then up to the north. On the right, there's these options that we have. We'll go through them a bit later, but we could change the color here, and we could do a lot of things right here in this moment. But well, this is the simple one. But if we go again to the operations, Brad allows you also to select the data and not have the entire track. We could only want, for example, to view the ocean data, not the ones overland. Apart from that, and we'll see this selection criteria, how it works now. We just now we plotted a parameter that is inside the product, but what do we do if we want to plot something else, like sea surface height and sea level anomaly, and we don't have it in our product? Here in the data, we can create a new expression. Let's just call it sea surface height. And then here in the expression, as we don't have any field in our product, we can't drag it, but we can insert a formula that we may have built previously, or we can use the ones existing in Brad. Here's the list of it, but you have to know what formula to use because there's plenty of them, and they are quite similar. You can see that for one mission, you have 3 sea level anomaly formulas, for example, and the same for the sea surface height. But well, Once we click on it, we see the formula down here in the content. And once we click OK, we see it here in the expression. With this, if we play execute, we will see the log again. If we go to the views, we generate a new, and we say MVSAD surface height. We open it here, and we see that we have two, but in this new display, we only want to plot the surface height. So we put it on the right, execute it, and now we have here the variables, the values for the surface height for this track. Okay, and we can also view it in a not on top of the globe. We may be interested in just seeing it as a line in a 2D plot. So we generate a new operation with the same data set, but now we are only going to put the latitude in the X component, and the data, we insert an expression, we will use the same one. Here, and now we execute again, and we'll see a different plot now. New plot, MVSAD, SSH, 2D. And now here we have the Z plots and the Y plots, just the two-dimensional plots that we can put here. And when we execute them, we see totally different plot. And well, a feature that Brad has is that we can select data, not only by cutting in latitude and longitude, but we can also use the parameter that the products have inside. So we go back to operations, and here in selection criteria, we can use this variable, which is a flag that indicates if the surface that's been observed is ocean or is land or ice. And if we drag the mouse, if we put the mouse on top of the variable, we see the content of it. For what matters us now, we just want data over ocean, so the flag is 0. And we execute this again. Let's name this surface height. We execute again. No, yeah, okay. So we do the same plot as we did before, but just filtering the data. If you compare the two, we see that we don't have these big peaks that we had in the first picture. There's the option of plotting all the variables in the same plot, but then we need to have both at the same time here. We could do that, but no, it's I'm just showing you a bit how it works and what we can do. So this is for tracks, and I think that now we could see some merge data, because Brad can do a lot of stuff. We're going to create a new data set. Let's put grid data. We will add this file. We will see mean sea level anomalies. This is data that's in the website, available to anyone. We go to the operations, we create a new operation, and we select now the second data set that we have. We can have as many data sets as we want, but when we build an operation, we have to choose the data set that we want. Now we're going to see how it looks in the Brad viewer. Grid data here. So we will just plot, click on execute. It will take a few seconds. Once it's done, we can go to views, generate a new display with the grid data map. We select in the Z component plots the one that we want, which is this grid. And we can click on execute and see how it looks. Now here we have mean sea level anomalies over the whole globe. You can edit the colors here in this tab. You can change it to cloud, apply it, or green to red, apply it. Well, there's a lot of options here. And well, we could change the range also. Let's go back to the first color code. Here we may be interested in, I don't know, maybe the positive ones. So we can reset the values, and the values that are not within this range, they appear in black. But just to see that you have a lot of options here. Apart from that, the options could be also modified in the operations tab, where we introduce this. Apart from the selection criteria that we could use, like only ocean or only ice, we have this option here in set resolution filter. We can filter the data here, only having the positive longitudes, for example, or I don't know, this ones, and just latitudes that are positive. Also, here the steps, and also if we had some blanks in our data, we could do a little bit of interpolation here, choosing the filters that we want. Remember that we used some formulas here before. In this expression box, the users can type their own formulas and then save them for later uses. Also, note this. And well, once that we've done this resolution, which we've set the filter, we can execute again. Wait a few more seconds, and we'll see that we only get the data in the limits that we set. Yeah, now it's done, and we can generate a new display or plot it in the same display. Yeah, we'll see. And now we only see the data here. And one last thing that can be done when using several data sets in the computation, in the operations tab, here we can choose the operation that we want when we have data in the same place, when it's overlapped. For graded data, we can choose to do the mean, or maybe we're interested in the standard deviation of the whole data set that we have. Well, this is a quick view, maybe too quick for the Brad, but it's to get an idea of what we're talking about. So let's go back to our presentation, and now we're going to see the new features that we have, or that we want to introduce in our toolbox. We can group them in 4 categories. We'll have new data sets. We want to include new functionalities. We will have a new design, which is an important part of this webinar. And then the user support and interaction part. We'll see that later. So for the new data sets, now the toolbox will be NetCDF4 compatible, which means that we'll be able to read Sentinel-3, JSON-3, HIN2, SARAL, and the reprocessed data, and well, all the files that are NetCDF4, and also the previous versions, but also all the formats. For us, it's a big deal that we can now use Cryosat-2 data for baseline C. It has been the libraries have been adapted, and we will also be able to read data from Geosat, from the Hydroweb products, ESA River and Lake products. And the new feature that we want to include is to be able to synchronize with the RADS database, which is a huge database and it's widely used, I think, in the altimetry community. And well, we'll see how we could integrate that, but we would like to know if the users are interested in this integration. We think it's useful, but it's good to have your feedback. Then for the new functionalities, we already mentioned that it's NetCDF4 compatible, but we will have a new computation approach, which we intend to be multi-user friendly, which means that for the beginner user, as we saw, it's not straightforward to generate some plots or export data. So we will have some predefined measurements or like sea level anomalies, so the user doesn't have to go through the product and find the fields that are of interest. And also some selection criteria also already predefined, so the user can set that only ocean option or only land and stuff like that. Apart from that, from the more expert users, now they only can provide their own algorithms in C or C++, and there's the option or the objective of including the Python API in the toolbox, so it's easier to include new algorithms for many users. Apart from that, currently from the toolbox you can export KML files to view in Google Earth, but it's only an export of the image, the GeoTIFF image, which is geolocated image. What we want to do, well, it's already done here, but internally, it's we will include more information about each record that is plotted in the Google Earth environment. Moreover, there's the porting to 64 bits systems, which is quite good, and there's the intention of performing an analysis on importing the toolbox to the GPOT, which is the online platform from ESA. And from this analysis, we'll decide if it's feasible or not. Now, for the new design, we have an idea. So this is a concept design, as we said at the beginning, but we would like you to provide feedback and point out the strengths and the weaknesses of our design, and what ideas would you propose or what needs you have and we have not included them. But what we want to do is that let's make an easy toolbox for the users, so it's not complicated, and once you see the user interface, it's easy to start, and it's not, I mean, it's not complicated, so users are willing to start working with that. We want to have a workflow that is only 3 steps, which is data selection, data management, and in the end, export and view inside the toolbox. So here's our design. You can see that, well, here on the top, you have 2 drop-down menus for data selection and data management. We'll go through them just after this slide. On the bottom left, there's the configuration tools for the toolbox. Next to it, there's the visualization tool for plotting and mapping, sorry. A quick link for saving the data set that we've been selecting and tuning and managing. And then the one-click button, we'll talk about this later. And on the bottom right, you can see there's the information button, which is the user manual for the toolbox, ESA web pages, product formats for for the other missions. On the right, we have then the about, which is it provides information about the toolbox itself, its version, the revision, and finally we have the exit button. Well, let's go through the menus and see what options will we have, or the options that we have proposed. First, in the data selection, we have 4 options, which are source, time, area, and mission. So if we start with source, you see that we have included here the RADS synchronization, and we also have the option of the local folder. The good thing about the RADS is there's a huge database, and we don't have to download the products in our computer, on our hard drives, but we can also check that option. If we go to the next menu, which is where, we can choose from a few options, which are, well, quite useful. We can use square boxes, but we also have the option of drawing a free polygon, so the user can make their own masks without having to include it in the processing. Then there will be a list from predefined areas like Antarctica or Pacific, or well, a set of areas that will be comfortable for users that don't know what to look or are just curious, maybe. And also we could, we will be able to import from KML files areas that have been defined in the Google Earth previously, or in other applications. Then when we have when we select this data, we will be able to select from absolute dates or relative dates, which is quite useful because you don't have to know the exact date if you only want 1 month, the last month, or you want a month from that time, and we don't have to search in all the products. Then if we go to mission, you see that we will be able to choose within a lot of missions and also product levels. And a good thing that we want to include, we think it's a good idea to include, is to visualize the tracks of the satellites that we have selected. And then in this multi-mission environment, it's quite useful to view the tracks and see what tracks that we may need, or see if they overlap or not before performing all the operations, which is it will take a lot of time, and this way it will save a lot of time to the user. And now, if we switch to the data management menu, we see that we have 3 options: Quick Look, Advanced, and Expert. This is more or less the 3 levels of knowledge that we can have from the data products, the Altimetry products. So the Quick Look is mainly focused to the novice user, to the beginner, or maybe if you just want to view something quick and not have to edit or search through the product, where are the fields or magnitudes that we want to plot or check. So we proposed these 5 magnitudes, but well, we could propose more. We are expecting you to propose maybe other parameters, maybe not these ones. Well, it will be an easy thing and quick thing to visualize these parameters in the globe or in plots, and they will be predefined. So it doesn't require any processing or further knowledge of the products. Then for the advanced users and expert users, we're still working in which libraries to use and which environment to use. We started just a few months ago, but the advanced user would be the one that already knows the products, that is able to introduce its own formulas, its own selection criteria. And the expert user would be the one that would be ready to include algorithms, Python hard-coded or C-coded algorithms. And what we would like you to provide us feedback here is for the features that you feel that you need when you're using toolboxes, or what features would you use if you were to use a toolbox. And now we go for the last feature in the user interface, which is the one-click button. This is very useful for those users who perform very repetitive tasks. For example, checking every month the data in a set area, predefined area, and they have to do over and over again these things. So in our toolbox, they will be able to store this whole processing, data selection, data management, and time selection, and not having to include the new dates all the time. So it would be like this. You can see the screen now. In this one click, you have several options that the user has predefined. And if you see, the first one is Sisyphus Heights, Sentinel-3 in Lake Baikal for the last month. If you, well, we've used a few toolboxes from until now, and what we can do only is save the areas that we want, but saying the last month, this is, well, it's not easy. You have to set the dates and look for the area and then process the data that you want. Here, the user would be able to do all this in just one click, selecting and then processing the data. And then we go for the last feature of the project, which is the Altimetry portal. It already exists, but we will, as we said, we will update it and create new contents. So with the Altimetry portal, the user will be able to, will be soon available. The user can download the toolbox and the user manual, have access to data, and then have access to the open source code of the app. And what we want with this is for users to play with this code and then propose modifications and add new contributions if it's their need. And then through the contact help desk, apart from providing help to the users that have questions or concerns about the toolbox, through the help desk, we will provide this repository and control of the new codes. The consortium will approve these contributions then, and from that moment on, they will be available for the rest of the users. And apart from that, we will include video tutorials that will be available in the website and also in the toolbox. We wish that we are able to do this. And these video tutorials will be coming from inside the consortium and also from users that want to provide information to other users and stuff. And well, this is the review, the preliminary design that we have for our portal. You can see on the top that we have all the menus that can be also selected on the bottom in these square links. We see that we have, well, in the middle, there's this animated GIF with all the missions within ISA and the time with a timeline, just a fancy thing. For the toolbox menu, there's the main page for download and documents for the toolbox. Then there's a section for the code where the user can download it, propose modifications, etc. For the data access, it will include data products from several missions. And in the webs and documents section, there will be a catalog of the ESA main reference documents and websites of the Altimetry missions. This is more or less the same as the current one, the current tutorial. And apart from that, we see the bottom left that we have the tutorial and the SAR tutorial. The tutorial will be just an update of the existing one, which is quite complete, but there's a few concepts that have arisen. And also we will include the SAR tutorial, which is completely new to the current one. Apart from that, there will be the use cases, which will be practical examples of the application of altimetry data with instructions to for how to process that data and useful instructions for the users. And finally, the contact, where all the users can provide their concerns or inputs to the project. And well, on our side, this is all, and that's our project. We would really like you to provide feedback on our idea. I'll provide, well, we have a quick survey that it will take you 1 minute or 2 minutes tops. It would be very helpful if you could fill the survey. I'll circulate it through the chat if you want, but also you will receive it through the email. Well, I cannot find how to share this with you, but well, you can print the screen, or you will receive this link through the email from the consortium. And well, thank you very much for listening. This has been a quick look over our project, and we encourage you to provide feedback. It is very useful for us. And yeah, that's all. Thank you very much.